The purpose of this video is to bring up a solution for a problem that apparently quite a few people are seeing. I've seen it myself and had an issue with it, and that is when using a less expensive helmet and doing low current TIG welding, these auto darkening lenses will sometimes flash you. They won't trigger in the first place from the small arc from the TIG weld. I'm talking about miniature TIG welding or small precision TIG welding. Some of these helmets come with two sensors in the front. This one's got two. This is a Northern Tools helmet, and then this is a Hobart that costs a little more. I think that this first one here must have cost me about 30 bucks or something, and this one I think was about 60, but it too only has two sensors. And so the problem doesn't exist with MIG welding. The arc is bright enough to easily trigger it, and of course arc welding would even be brighter. But the issue exists mostly for TIG welding and low current TIG welding, less than 10 or 15 amps. So if you're having a problem with getting flashed from your helmet, there's two or three things actually that could cause it, and there are already videos on YouTube discussing some of those. One of those would be cleaning the lens for your helmet, especially if it's scuffed up to a point where there's dirt or marking scratches that are in the way of the sensors that would prevent good sensitivity. The other thing would be, and the other suggestion that's on YouTube quite a bit, is to try replacing the battery. Now some of these use batteries and some don't. This one here does not use a battery. It's totally solar powered. And the suggestion is, if you're having flashing with those, is to leave that out in bright light for a while to let it charge up the internal battery. There's a non-replaceable rechargeable battery in those. And then this type here has a battery and the solar lens in there, and they're used together. But the sensors typically are not those solar cells up here. There's these little points here behind which are photo transistors. Now these look a little bit different here because I've dorked with them, and I'll explain that in a minute. But two sensors, and they have photo transistors behind them that do the arc sensing. Now as you get into more expensive helmets, they will typically have 4 sensors instead of 2. And as you go higher in price, another feature that they'll add is electromagnetic field sensing. So there's a coil built into the circuitry that can pick up high frequency that an arc would generate. And so it uses that in conjunction with the sensor transistors to be sure that it doesn't let up or flash you in the middle of a weld. So the more expensive helmets will typically have a rating that's shown in the specifications for minimum TIG current welding. And what's typical is it'll either be 2 amps or 5 amps. And there may be others. The few that I've seen fell into one of those two categories. So those are ready to use for low current TIG welding. Otherwise, it's common to have problems with these cheaper helmets, and I have had issues. This is one I use most of the time. This was one I started with. And just recently I was working on a small metal box and welding a small hinge in place, stainless. And so a very low current was needed, and just right in the middle of it, it would let up. It would lighten the lens and let it flash me. Now fortunately it wasn't a high enough current to be a real bright flash that caused problems for my eyes. I quit welding in time to not have an issue, but it's something you don't want happening while you're welding. So I just brainstormed and had an idea that I tried here, and it worked great. And I want to just make that available to others that are using less expensive helmets. Typically, you know, beginners running on a budget, just learning TIG welding. You know, they've got $20 helmets, and they got $50 helmets and $100 helmets, all the way up to you know, excess of $1,000 for fancy ones. But I did a change on these, and it has worked great. Now what I did, if I can get the light just right, you can see that over the sensors is a little bubble. And what I did is I put a piece of acetate, just, you know, the stuff you'd use to make transparencies, which aren't used much anymore with the LCD projectors and that kind of thing. But I just took a sheet of that and cut out a couple small pieces out of it. I don't know if I can make that visible here or not. Anyway, just a couple small pieces that when you look here, you can see I used a piece of acetate over this sensor, and the same, if you can see that in the light and the glare, on this one. And there's a couple drops of glue. I used UV cured glue. That would be this stuff. And it just, it's almost a gel when it comes out. And I'll try and insert a little video in here of demonstration of using that. But what I did is just held that acetate in place with a couple drops of that glue and cured it with a, you know, just a UV flashlight goes with the glue, and it causes this glue to harden. Now it hardens with a little film of oil on it, and if you try and clean that off, sometimes it dulls the little glossy bubble that it makes. So I wouldn't touch them once you put them in place and cure them. Just keep them as clear as they can be, and put them in place that way. Now what we did, after we put that acetate in place, I put enough of a bubble of that same UV glue to make a lens. And then before it ran out too far, while it was still in a bubble, bubble's not the right word, but a bulge, while that was rounded, I hit it with UV light and cured it in place. Now that lens that we just made on there increases the sensitivity quite a bit of the sensors that are there. And this helmet is no longer flashing me. Now I did the same thing on this one, except the sensors on this one were recessed. You couldn't see the top of the sensor unless you were looking straight on. And so that kind of makes it, kind of defeats some of its use. If you get off to the side a bit with your weld, that sensor can't see the arc. And that was probably one of the original reasons why I set this helmet aside and purchased a new one. But what I did here is just I took the lens out of there and laid it flat. And then I put drops of glue into the holes where those sensors are, and filled up that little cavity, and then let it finish off with a little bulge on the top, making a lens. Then hit that with UV and cured it. Now that solves two problems. It increased the sensitivity enough to where now that can be used with low current TIG. And it also, the way that bubble conducts light, and back into the channel, it works kind of as a light pipe. And so now the angle of where the welding is in relation to the placement of the helmet makes very little difference. So it was quite a successful experiment. Now I'll try and put together a little demonstration showing how I put that glue in place, and put that into here. We'll make a video, and hopefully it'll help some of you. Thanks for watching. The dot that's on here is going to represent the sensor, one of the sensors on the auto darkening lens. And you can see I'm going to put a piece of acetate right over it, and then I'm going to use the UV glue to hold that piece of acetate in place. We'll put a drop on each side. This is easily removed if you screw up. Then I'm going to take the UV flashlight and expose it for 10 or 15 seconds. To cure that glue. Okay, if we can get that to refocus, there we go. So that acetate now is covering the hole where the sensor is in the auto darkening faceplate. Now what I'm going to do is put a couple drops right over the sensor. Whoop, you don't want any bubbles. So if you have bubbles, you'll want to see if you can pop them. I shouldn't have done that so fast because normally it doesn't make bubbles. But anyway, you want that area to be itself a bubble. Not of air, but air, like that. I'm going to expose that to UV. So basically that cures in a magnifying lens shape. I don't know if you can see that from the, it's not really a profile shot, but so we'll let that cure. Okay, and then you'd repeat that same thing on the other sensor for a 2-sensor self-darkening lens. You'd do it on all 4 if you wanted to on a 4-sensor lens if you're having trouble with it picking up your low current TIG welds. Typically I don't think 4-sensor ones are going to have the trouble, but the cheaper ones might.